This lesson, we are going to learn how to solve rational inequality. A rational inequality is an inequality which contains a rational expression. The trick to dealing with rational inequalities is to always work with zero on one side of the inequality. Rewrite the question if necessary to obtain a zero on one side. Then, the x value that makes the numerator zero and the x values that make the denominator zero will determine the number line test values. The trick to dealing with rational inequalities is to always work with zero on one side of the inequality. Rewrite the question if necessary to obtain a zero on one side. Then, simplify all fractions into one fraction. Determine the roots or the zeros by letting numerator equals 0, and determine the restrictions by letting the denominator equals 0. After we have the zeros and the restrictions, we put them on the number line to check the positive or negative sign for each of the intervals. Then, we use our inequality to make our conclusion. Example 1. We have a rational inequality, step 1, that's move all the fractions to the left-hand side to obtain a zero on the other side. Next, let's make a common denominator to combine those two fractions into one fraction. Then, we let the numerator equals 0 to find our zeros, which is at x equals 13. And we let the denominator equal to 0 to find the restrictions. As you can see, there's no variable in the denominator, so we don't have any restrictions. Let's draw a number line, put the zeros on the number line. Now we are ready to check the positive negative sign. For the right-hand side interval, we use x equals 20 to substitute into this rational expression to check the positive negative sign for the y value. You will see the y value will be negative. Next, we're going to choose x equals 10 for this interval on the left. Substituting to this rational expression, you will see the y value will become positive. At the same time, for our inequality, we do not see an equal sign there. That means the 0 is being excluded. Finally, let's look for our solutions. We want our function to be smaller than 0. That means we are looking for a negative region. Therefore, we say x is element of 13 to positive infinity. Example 2. Now we have another rational inequality that is already simplified and having a 0 on one side of the inequality. So, let's find the zeros. X minus 2 equals 0 means x equals 2. Restrictions. X minus 3 can never be 0 means x can never be 3. Let's put it on the number line and check the positive and negative sign. And we can see on the most right-hand side interval will be positive, then the middle interval will be negative, and the last interval will be positive again. And since there is an equal sign on the inequality, that means we do include the zeros. However, the restriction can never be included, so at 3 is an empty dot. By looking at our inequality, we know we are looking for the positive regions as our y value is bigger or equals 0. Therefore, we say x is element of negative infinity to 2 square bracket, including the 2, union, round bracket at 3 up to positive infinity. Example 3. First, subtract a over x to obtain a 0 on one side of the inequality. Step 2. Let's find a common denominator between all three terms to combine them into one single fraction. Step 3. Let's factor the numerator into x minus 4 times by x plus 2 in order to find the zeros and the restrictions. Step 4. Let's find the zeros. X minus 4 equals 0 means x could be 4. Or x plus 2 equals 0 means x could be negative 2. Restrictions. X can never be 0. Now, let's put the zeros and the restrictions on the number line and check the positive negative interval starting from the most right-hand side. Then we will get positive, negative, positive, negative. Since x can never be 0, so at x equals 0, it is an empty dot. And there is no equal sign on the inequality. That means both zeros will be excluded too. Now, according to our inequality, we want to look for the regions where the function is smaller than 0. That means we are looking for negative regions. Therefore, x is smaller than -2 or in between 0 and 4. Example 4. Step 1. Let's isolate all the rational expressions to one side of the inequality to have a 0 on the other side. Step 2. Let's find a common denominator in order to combine those two fractions into one single fraction. Step 3. Let's find the zeros. 10x plus 2 equals 0 means x can be -1/5. Restrictions. X minus 4 cannot be 0 means x cannot be 4. And x plus 2 cannot be 0 means x cannot be -2. Next, let's construct a number line and check the positive negative sign for each interval. Starting from the most right-hand side, it will be positive, negative, positive, negative. Since there's no equal sign on the inequality, the zeros will not be included. And the restriction will not be included either. Finally, let's look at our inequality to look for the solutions. We want our function to be smaller than 0. That means we are looking for negative regions. Therefore, x is smaller than -2 or in between -1/5 to 4. Example 5. First, remove the rational expression from the right to the left to make a 0 on the right-hand side of the inequality. Step 2. Find a common denominator, which is x minus 1 times by x plus 1, and that's combine those two fractions together into one single fraction. Then, let's find the zeros. That means x plus 3 equals 0 means x equals to -3. And let's find the restrictions. X minus 1 cannot be 0 means x cannot be 1. And x plus 1 cannot be 0. That means x cannot be -1. Then, let's put it on the number line to check the positive negative sign for each intervals. From the most right-hand side interval to the left will be positive, negative, positive, negative. Since there's no equal sign on the inequality, the zeros will not be included, and the restrictions at 1 and -1 will also be excluded. Finally, let's look at our inequality. We want to find the region such that the y values is greater than 0. That means we are looking for positive regions. Therefore, x is in between -3 to -1, union 1 to positive infinity. Example 6. Step 1. We need to have a 0 on one side of the inequality, which we do have already. Step 2. Let's factor the rational expression that is on the left-hand side of the inequality. So first, let's factor the -1 in front of the x, and the first bracket in the denominator can be factored into x minus 3 times by x plus 2. The second bracket can be factored into x minus 3 times by x minus 3. Then, let's simplify the rational expression that is on the left-hand side. Then we're going to have x minus 3 to the exponent 3 times by x plus 2 in the denominator. Now, we can move on to find the zeros and the restrictions. The zeros could be found by letting the numerator equals 0. So, x plus 7 equals 0 means x equals -7. And x minus 5 could be 0 means x could be 5. Then, let's find the restrictions. Denominator can never become a 0. So, x minus 3 can never be a 0. That means x can never be a 3. X plus 2 can never be a 0 means x can never be -2. Now, let's construct a number line to put all the zeros and restrictions on to check the positive negative sign for each interval. Because the leading coefficient is negative, that means the most right-hand side interval will be negative. When we go through the number 5, the 5 was coming from this bracket. The exponent is 1, which is odd, so we switch the sign to be a positive now. When we go through the number 3, 3 was coming from this factor. The exponent is 3, which is odd, so once again, we switch the sign. Next, Let's go through the number -2. -2 was coming from this bracket here. And exponent is 1, which is odd, so we switch the sign. Last one, we go through the number -7. -7 was coming from this factor here. The exponent is even, which is a 2. Then we keep the same sign. Let's look at the inequality sign. Since there is an equal sign on the inequality, that means the zeros will be included. So -7 and 5 will be a solid dot. And restrictions will be an empty dot. Finally, let's look at our inequality to make a conclusion. Since we know we want our rational expression to be greater or equal to 0, this means we are looking for the positive region. That means x will be an element of -infinity all the way up to -2. Round bracket because that's an empty dot. Union from 3 empty dot all the way to 5 solid dot.